Good morning, students. I am Dr. Ritika, the faculty of CSC department, as an associate professor in St. Andrews Institute of Technology and Management. Today, I am going to deliver the lecture on the subject of software engineering, which is related to the BCA 4th SEM. And today we will cover the topic of software reverse engineering. So, students, let's come to learn more about the software reverse engineering. Now, what is reverse engineering? We will learn about reverse engineering. Now, what is reverse engineering? You have an unexpected cases. You finished one project using Java. Your program run fine, but by accident you delete the Java files. How to handle this in your program? So the question of above answer is related to these questions are reverse engineering. Now, what is reverse engineering? Reverse engineering is the process of discovering the technological principles of a device, object, or system through analysis of its structure, functions, and operations. Once again, students, it is the process of discovering the technological principles of a device, object, or system through analysis of its structure, functions, and operations is known as reverse engineering. It often involves taking something like mechanical devices, electronic components, software program, or biological, chemical, or organic matters. All are the apart and analyzing its working. Now let's take an introduction about the reverse engineering. Reverse engineering is taking apart an object to see how it works in order to duplicate or enhance the object. The practice taken from older industries is now frequently used on computer hardware and software. Some software reverse engineering involves reversing a program machine codes. The machine code means the string of zeros and ones that are sent to the logical processors back into the source code that it was written in using program language statements. In terms of software, to retrieve the source code of a program, to study how the program performs certain operations, to improve the performance of a program, to fix a bug is related to the errors, related to the faults, and last is to identify malicious contents in a program. Reverse engineering application. Here are the some application related to our reverse engineering. First is security related. In security related, reverse engineering has been employed in encryption research. Second, with malicious software on both ends of the fence. Some crackers all are related to our security related aspects in the applications of our reverse engineering. Next is a software development related. In software development related, it evaluating software quality and robustness, achieving interoperability with property softwares. Now next is developing competing softwares. All are related to our software development related applications in reverse engineering. Now need. Why we need of software reverse engineering? Let's learn about why we need of reverse engineering, or you can say software reverse engineering. So a software reverse engineering is done to retrieve the source code of a program because the source code was lost, to study how the program performs certain operations, to improve the performance of a program, to fix a bug. Bug is related to your error in the program when the source code is not available. Second, to identify malicious contents in a program such as virus, or to adapt a program written for use with one microprocessor for use with another. So here are the needs of reverse engineering. First is to improve the performance of a program. Second, to fix the errors or bugs. Next, to identify malicious contents in a program such as virus. And last is to adapt a program written for use with one microprocessor for use with another. These are the needs of our software reverse engineering, which is to be done to retrieve the source code of a program, because the source code was lost, then to study how the program performance can be done on certain operations. To improve the performance of the program, we have done about the, or we can say need about the reverse engineering or software reverse engineering. Why do we need that is reverse engineering? Here are the some reasons related to the need of our reverse engineering. First is product analysis. In product analysis, to examine how a product works, what components it consists of, estimate cost, and identify potential patent infringement. So these are the way how which you can analyze the product. Second, lost documentations. The reverse engineering often is done because the documentation of a particular device has been lost or was never written, and the person who built it is no longer available. Then we need of our reverse engineering. So here are the reason. First is product analysis, second is the lost documentation. Next is the software modernization. In software modernization, in order to understand the as is state of existing or legacy software, in order to properly estimate the effort required to migrate systems knowledge into a to be state. So it is the order to understand as is state to be state. So next is the learning. Now learning from another mistakes. So do not make the same mistakes that other have already made and subsequently corrected. So here are the next two reasons that we need of our reverse engineering or software reverse engineering. Now next third is software modernizations and learning. Now the reason the original manufacturers of a product no longer produce a product. Next, the original manufacturer no longer exists, but a customer needs the product. Next, to analyze the good and bad features of a competitor product. Next, strengthen the good features of a product that is based on long-term uses of the product. Here are the some different reasons which is related to our software reverse engineering. Some previous four are product analysis, lost documentation, software modernization, and learning. Expect instead of these four, we need of reverse engineering in the manufacturing of the product where no longer product is produced and original manufacturer no longer exists, so customer needs of product. Here to analyze some bad and good features related to our product, which is done by the competitor environment. And last is the strengthen the good features of a product which is based on the long term uses of the product. Now here are the some benefits of why do we need re-engineering, that is reverse engineering. We need some benefits like understand existing design, quality improvement, competitive advantages, software reuse facilitations, and last is no need to start from scratch. All are related to the benefits of our reverse engineering. So, next two levels of reverse engineering are: first is system level reversing, or you can say system level re-engineering. First is in system level, the running various tools on the program and utilize various operation systems services so to maintain information, inspect programs executables, track program input and outputs, and so on. So these are the system level reversing. Now, code level reversing means extracting design concepts and algorithm from a program. Observe the code from a very low level. Many of these details are generated automatically by the compiler. Now, here are the some software engineering. Here are the forward engineering and reverse engineering. In forward engineering, it works on requirement analysis, design, and implementation. But in reverse engineering, in forward engineering, it works from top to bottom. But in reverse engineering, it works from bottom to up and follow the steps of implementation, design, analysis, and requirement. So here are the software engineering which is based on the forward engineering and based on the reverse engineering. Now procedures to collect information, to collect all possible information about the program. Sources of information which include source code, design documents, documentation of system calls, and external routines. Examine information. In examining information, it review the collected information, a plan for dissecting the programs and recording the recovered information that can be formulated during this stage. Extract structure is to identify the structure of the program and use this to create a set of structure charts. Each node in the structure chart correspondent to a routine called the program. The chart records the calling hierarchy of the program. Next is the record functionality. For each of node in the structure chart, records the processing done in the program routine that is corresponding to that node also. Now next, record data flow, the recovered program structure that can be analyzed to identify data transformation in the software. The transformation steps shows the data processing done in the program. Record control flow which identify the high level control structures of the program and record it using control flow diagrams. It also refers to high level control that affects the overall operations of the software also. Next is the review recovered design. The review the design to verify that it correctly represents the program. It also identify any missing item of information and attempt to locate them. Next is a generate documentation. The final step is to generate design documentation. The information explaining the purpose of the program, program overview, some history, etc. will need to be recorded. Now next is the reverse engineering tools. Here are the some tools which is used in our reverse engineering. First is system monitoring tool. The system level requires a variety of tools that sniff, monitor, explore, and otherwise expose the program being reversed. It displays information gathered by the operating systems about the application and its environment also. Some disassemblers which converts X to assemble as best as it can. Relatively simple process, sometimes difficult to understand also. Debuggers, the reverse engineering, or we can say software reverse engineering, use debuggers in the assembly mode. They can install breakpoints in locations of interest in the disassembled code and then examine the state of the program also. Decompiler. The decompiler is a binary program into high level source language. So it can replace all binary code that could not be decompiled with assembler code. Some pros and cons. So the reverse engineering is related to some pros and cons. So let's learn about some pros and cons of our software reverse engineering. In the pros are that if you do it right, you can produce the item in questions without having to design it from scratch. Now the major cons is that if you do not follow some very complex rules, you can wind up a legal trouble for stealing the original manufacturer's intellectual properties. Now type of our RE, that is reverse engineering. The hardware reverse engineering involves taking apart a device to see how it works. For example, if a processor manufacturers wants to see how a competitor processor works, they can purchase a competitor processors, deassemble it, and then make a processor similar to it. Another type of reverse engineering involves the producing of 3D images for manufacturing part when a blueprint is not available in order to remanufacture the part also. So students, before going to close our slide, let's take a little bit revision what we have covered in our slide related to the topic of our software reverse engineering. So in software reverse engineering, firstly we have covered what is reverse engineering. So we have covered firstly we have covered the questions which rise in a human mind which are related to some unexpected cases. Finished one project using Java, program runs fine. By accident, if you delete some Java files, how to handle your project? So above mentioned all these questions, only solution is the reverse engineering. Then we have covered what is reverse engineering. So it is the process of discovering the technological principles of a device, object or system through analysis of its structure, functions and operations is known as reverse engineering. And next we have covered some reverse engineering involves like mechanical devices, electronic components, some software programs, biological, chemical or organic matters, a part of analyzing its working also. And in next slide we have covered about the introduction to the reverse engineering, and then we have covered in term of reverse engineering in term of software. Next we have covered some applications of our reverse engineering like security related, software development related. Then why we need of reverse engineering, we have covered three topics that we need of software engineering. Reverse engineering, first to improve the performance of program, second to fix the bug, and third is to identify their malicious contents in a program such as some virus or adapt some program that is written to the use with one microprocessor for use with another. So to find out of all these things, then we need of our software reverse engineering. Then we have covered some reasons related to the need of software engineering, like product analysis, lost documentation, software modernization, learning. Here are the some other reasons we have covered which is related to the need of our reverse engineering. Some benefits we have covered, benefits of our reverse engineering. Then we have covered some levels of our reversing, system level reversing, and the next is the code level reversing. Then we have, with the help of this diagram, we can understand what is forward engineering and what is reverse engineering. With the help of this diagram, we can easily understand how forward engineering work from top to bottom, and how reverse engineering can work reverse function like bottom to top. So these are the steps related to our forward engineering and reverse engineering, and these steps are requirement analysis, design and implementation, on the basis of which software engineering to be worked from forward engineering and reverse engineering. Next, we have covered some procedures like collect information, examine information, extract structure, record functionality, record data flow, record control flow, review recovered design, generate documentation, system monitoring tools, then deassemblers, debuggers, decompiler, and we have covered some pros and cons related to our software reverse engineering, and the type we have covered where which we need of our reverse engineering in hardware reverse engineering, which is related to the device to see how it works, and in 3D images, which is very helpful for manufacturing part also. Then it is all about our reverse engineering. So student, we have covered the topic of our software reverse engineering, or you can say reverse engineering, or you can say RE. So all are same thing, no need to confuse. If examiner will ask you what is software reverse engineering, what is reverse engineering, or in short form, if he ask you what is RE, all are the same thing. So students, thank you very much for your kind attention. Thank you students. Have a nice day. Thank you.